Hi, now we are going to discuss about the N-type MOSFET. In the N-type MOSFET, we are having the agenda of MOS capacitor, accumulation, depletion mode, inversion, N-type MOSFET construction and working. We'll discuss one by one in the each slide. First, MOS capacitor. This structure commonly referred as a MOS capacitor is connected to the two terminal device with one electrode to the metal and the another electrode to the semiconductor. A voltage dependent capacitance as a result. Next, accumulation. In the accumulation, we are applying negative voltage to the metal and we are having the electrons as the majority charge carriers in the metal, the negative and the negative terminal and the negative which is present in the which is present in the metal, that is electrons, will repel each other and accumulate towards the SiO2 layer. That means accumulate towards the depletion region or layer. And one another terminal is connected to the P type. In the P type, majority charge carriers are the holes, and this positive terminal and the P type will repel each other and they try to accumulate towards the SiO2 region. This is called accumulation. Depletion. Here we apply positive voltage to the metal. We are having the electrons, that means in the metal we are having the electrons, that means negative charge, negatively charged. This positive and this negative will attract each other. In the P type, the negative and in the P type, the majority charge carriers are the holes. This P type and this negatively charged, positive and the negative, will attract each other. Negative ions attract towards the holes. So depletion region is formed. This negatively charged ions uh, attract towards the holes. Then the depletion region is formed. That means the SiO2 region is formed. Inversion mode. By using the parallel plate capacitor principle, if we give one potential, that means if we are giving the positive, then the opposite and the same, I mean equal number of the charges are formed. Here the electrons are moving below the electrons, in the metal we are having the electrons, that means negatively charged particles, which are moving below the SiO2 region, that means in the P type. That is inversion. Now the N-type MOSFET construction and working. In the N-type MOSFET construction, we take P-type semiconductor as a substrate. The substrate is P-type. We can add two N-layer N-type semiconductors. Two N-type semiconductors we are adding on the two sides of the circuit. We are having the three terminals, that is uh, drain, source and gate. P type. In the P type, the majority charge carriers are the holes. In the p type, the majority charge carriers are the holes. Minority charge carriers are the electrons. In the n type, majority charge carriers are the holes and the minority charge carriers are the electrons. When electrons and holes are mixed, then depletion region is formed. Source is connected to the negative. Drain is connected to the positive. Drain is connected to the positive. Negative voltage is going to source terminal. Negative voltage is going to source terminal. That means it's source terminal. And negative negative are repelled. That is, this is negative and this is negative. Are repelled with electrons. They repel each other. They repel each other. The electrons are moved in the p type. That means the electrons are moved in the p type semiconductor. Then depletion region will decrease. It helps the current will pass. It helps the current to flow towards. The positive drain terminal is affect with attract with the electrons. I mean, in the positive, the drain is attractive with electrons. Then depletion region of the drain will increase. This depletion region will increase, and it will stop the flow of the current. The current direction it will stop. At the gate, we apply positive voltage. Electron of the metal will attract the positive voltage. The positive voltage. Then it will charge a positive in the metal p type. Charge carriers are the electrons. Metal p type charge carriers are the electrons. Attract with each other. As a result, depletion region was decreased and current flow is formed. This current flow is formed. In gate, we apply certain voltage, then the flow of current is formed. Here we are applying some voltage, then the gate, from the gate the current is formed. Thank you.